Kia ora, Year 10. This is the last question from the 2017 exam, and it's one about bearings. So it's quite involved if you have forgotten how bearings work. If you're in my class, I've set you some good Education Perfect on this. And a bearing is another way of writing a direction. So let's quickly go over bearings for about 1 minute. Suppose that I am a boat and I want to get from here to here, right? This is massively simplified. So we've got A here and B here. And I want to have a description of the angle that that boat's got to go on. Well, the convention with bearings, it's more than the convention, it's kind of the way that they work so that everyone understands what's going on, is that we draw a north line from our starting point. And then we look at where we're trying to get to, and we measure the angle going clockwise from that north line all the way around. So if we've got a little angle in here of 30 degrees, the bearing is not 30 degrees. The bearing from A to B is going to be 120 degrees, right? So I'm measuring here. And that's the key to what you need to know for bearings. So in this exam question, we've got one where we have to draw the diagram in. So Northport is 450 kilometres due north from Southport. So from Northport, Ben heads away on a bearing of 240 degrees for 180 kilometres. So you can see up here, you can think about your north line. And Ben wants to go on a bearing of 240 degrees. So moving around, that means that when I move to here, I've gone 180. So he wants to go another 60 degrees in this direction. So let's rule in what Ben's going to do. So he's starting where that crosses. And this is where he's going first. So he's going for 180 kilometres. And that angle in there is going to be 60 degrees because this one in here is 180 degrees. Then he adjusts his course and he goes directly towards Southport. Now it might look on here like I've drawn some kind of regular triangle, but we've got no way to know just yet what that angle in here is. So we have to find, we'll call that point B, the bearing that he must maintain on the new course to reach Southport. So the bearing from B is not that pink angle that I've drawn in though. The bearing from B is this. Here's my north line, and this is what the bearing from B is. Now that actually makes it easier to see what to do. I don't have a right angle triangle in here yet, but if I take my ruler and draw a line in across here, you can see what I need to find. So let's call this point here point C. This is B, and we'll call down here, we'll call point B. So the bearing that we're looking for is going to be 90 degrees, this bit here, plus angle CBD. Suddenly this question doesn't look that bad because we know that this side is 180, we'll call this point A, and we know that this angle is 60. So I'm going to draw this out a little bit better, and we're going to start to find some missing things. Just get rid of some of the mess from the other videos. Okay, so we've got this triangle here. This just looks terrible without a ruler. Sorry guys, I'm going to stop and do it with a ruler. Okay, so that's a bit better. So we've got A, B, C, D, and this is 60, and this is 60 degrees, and this is 180 kilometers. We're going to call this X. So the first thing we can do in here is that we can work out what length X is using basic trig. So this is the opposite side, this is the hypotenuse, so sine of 60 degrees is equal to X over 180. So 180 sine 60 is equal to X, and X will be 155.8845. Now I'm not going to round that because I'm using that further on. Then the next thing that I can figure out is what this length is, Y. And that's, I don't even know if I'm going to need that, but I'm going to figure it out. I could do that using Pythagoras, or I could do it using trig. but I'll do it using trig. So cos of 60 degrees is equal to y over 180. Working that through the usual way, we get to, so cos of 160 is, cos of 60 is a half, so y is equal to 90 kilometres, right? So we can put those on. Now that helps me because of y is 90, so that tells me the next length that I need. So if this bit here is 90, so AC is 90, and that means that CD is the leftover on the 450. So CD is equal to 450 minus 90, which is 360 kilometres. And remember what we're looking for is this angle here, and then we're going to add 90 onto that. And now we've got that this is 155.8845. So what link up have I got? Well, that's a right angle. This is the adjacent side, and this is the opposite side. So the tan of the angle will be this. And we better give that angle a name. So tan of theta is equal to 360 over 155.8845. So theta is equal to the inverse tan of all of that. Which is 66.6 degrees. So remember that we want to answer the question, and the question is not what is that angle. The question is find the bearing that Ben must maintain on the new course. And the bearing is going to be, let's go back to the original diagram now and see what's going on. And we'll take off some of the extra stuff that's on here. So he's gone out 180 kilometres. This angle here is 66. Keep having problems with disappearing triangle sides. There we are. I don't think anyone's still watching now anyway. But hopefully you are, because the key to this question is that the answer is not 66 degrees. The bearing is going to be 90 plus that is going to be 156.6 degrees. All right, so there you go. Quite an involved question. Make sure that you've gone over the basics of bearings, that we always draw a north line in and we measure in a clockwise direction.